Yesterday we talked about absolute value theorem, and the absolute value theorem basically says, so let me rewind again. Absolute, my fault. Absolute value theorem. Oh, you cannot see my fault. Okay, absolute value theorem. They say if limits as n approach infinity of absolute value of a to the n is equal to 0, then limits as n approach infinity of a to the n also equal to 0. So does that make sense to you, or that's confusing? Now, for example, we're gonna deal with like a sequence as -1 over n to the n power. So if I say limit n approach infinity, right? So let's write out first few terms. Let's write out, we're gonna say, hey, this versus 1 over n. 1 over n is gonna be 1 over 1, 1 over 2, 1 over 3, and 1 over 4, and 1 over 5, right? Dot, 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 dot. But if it's -1 to the n, it's gonna be what? -1, right? Plus 1/2 minus 1/3, right? And 1/4 positive and negative 1/5, right? So if I were to plot in on the plot, right? If I plot in on the plot, what will happen? Well, for 1, 1, it's going to be 1, and this is 1/2. Well, I'm going to use a bigger scale. So this is a 1, this is a 1 here. And 1/2 is like this, right? 1/3 is like this, right? And 1/4 is like this. So basically graph's going this way, right? But it's still gonna go plateau into 0. Does that make sense? Now, what if it's alternating? The alternating is gonna be look like this. This point is the same. No, sorry, this point is gonna be opposite. Does that make sense? The second point is gonna be 1/2, so it's gonna be same point here. The third point is -1 over third, so it's gonna be 1/3 here, which is a little bit here. And this is a 1/4, which is gonna be here. Wait, hold on a second. This one is 1/3, and this is 1/4, and this is a 1/5. Right? So I have this point here. Right? But if I make an absolute value, guess what? This point is gonna reflect to become here, right? And this point is gonna reflect to here, and this point is gonna reflect. I'm gonna do a purple point. It's reflecting here, 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 here. So it eventually is still gonna go to 0. Regardless, this one's gonna be the same. These are an issue per computer way. What? For what? Has to be done right now, or how it gonna be done? All right, fine. So it's gonna be like this, right? Eventually, it's still plateau in 0. So that's why we say we can take the absolute value of it. Just look at the absolute value perspective, you're gonna get the same answer, regardless what happened. So why do I do this? So let's say limit n approach infinity of a to the n. So a to the n in this case is -1 to the n over n. So I can say, hey, let's do absolute value of this. That's going to be limits of n approach infinity. That's going to be use 1 over n, because negative 1 no longer, the absolute value just take a negative 1 completely away. And if this is going to 0, it still converge. Yes.
So when do we use absolute value here?
When you have a negative 1 to the thing, like to the sequence, so it's alternating, right? So if it's alternating, you can just put the absolute value it, because we say absolute value theorem. If the absolute value go to infinite is equal to 0, therefore the sequence of a to the n also go to 0, even though it's alternating. Yes. Always. If something's alternating between plus minus sign, which is you have either negative 1 to the n, or negative 1 to the n plus 1 power, or negative 1 n minus 1 power, or negative 1 to the n plus 2 power, doesn't matter. You can just absolute value it, the negative 1 to the n power is gone, because it's no longer a factor. Emily, I need to talk.
I understand this.
Okay, but I need to talk, move on, so. Okay. All right. Yeah, we are going to do the next section. So this is one thing that we say, if the f of x is continuous, it has to be continuous, and limits n approach infinity of the sequence a to the n is equal to L. Then if you have is a composite function, so limit approach infinity of f of a to the n, so it's f of a to the n. That's equal to f of limits at n approach infinity of parenthesis a to the n. And that's also equal to f of L. It's very, very intuitive. It's just like the function is a composite within another. Now we're gonna give you an example. Let's just say, huh?
That's equals L, right?
Yeah, that's equal to, yeah, it's equal to L. So this one is gonna be f of L.
Can you read it out?
Okay, so limit n approach infinity of f of a to the n, which is f of the sequence. So the sequence, we're gonna say the sequence is gonna go to infinite. And if they are equal to L, then they will be f of L. So you can replace that as L, and it will just say f of L. So for example, that if you ever have limits n approach infinity of e to the sine of 1 over n, so we're gonna treat this part first. So we're gonna say e to the x is continuous, because that's a function, right? And all we gotta do is pay attention to this small thing here, which is limit n approach infinity of sine of 1 over n. What is n approach infinity in this case? Sine of 1 over n. Yeah, it's 0. Does that make sense? So can I say that's e to the limits n approach infinity of sine of 1 over n? We know that's 0, so we can replace that 0. That's going to be 1. Okay, so we're going to test this concept again. We're going to talk about this concept again. So an equal to 10 inverse of x squared. Okay. Is tan inverse of x continuous function?
Yes.
Yeah, like there's no gap in those.
Yeah, it's not tan of x, right? Tan of x as asymptote at pi over 2 and negative pi over 2. But the inverse tan is switch that to this way, so it's going like this. So remember that the inverse tan graph I told you guys that you need to memorize on your test? It's going to be something like this, right? It is continuous function. And not only continuous, it's reach what? If we go to infinite, it's what? Pi over 2.
Does the x squared change?
Well, I mean, it's where the input number, but I guess it makes it go faster.
I mean, yeah, it would.
I think it would go, personally, I think it would go.
So what it be is tan inverse of limits n approach infinity of x squared. What is the x squared reach infinity? What is that? Tan inverse of infinity, right? So what is that? Oh, sorry, it's positive infinity. So what will be the answer? It's equal to pi over 2. That's why you need to know that this, because this second time we talk about this, and last time it's on the last test, remember? On the last test. Yeah, inverse sign. When they go to infinite, it's gonna go to pi over 2.
Wait, instead of x, you mean
Yeah. Yeah, you're right. So this one I'm gonna say n squared. Is that okay? Okay, key word that you guys need to understand. What is the key word today? The title of today, it should be monotonic. What does monotonic mean? And there's a few different ways to prove monotonic. Mono means one, good job. Tonic means alcohol. One drink. No. Emma, what are you doing on the weekend?
nothing. My sister's gonna order one.
Your sister's what?
She's gonna get a gin and tonic on the cruise. She's 21. She's gonna get one for Emily too. No, I'm gonna get a bean. But no, you need to go on over back.
Katie remind me I had to go to Bahama Breeze get those pineapple.
Yeah.
Yeah. I'm gonna have to go before they close down.
It's really good.
I'm gonna have to go before they close down.
It's just
It's so good.
I know.
Huh?
Have you ever had that?
Yeah, that we're talking about a pineapple, ultimate pineapple. Yeah, they put actual pineapple, right?
Pineapple, and they like hollow out the middle, and they like have a lot of half strawberry daiquiri.
Yeah, it's so good. Yeah, now I have to go get it now. Shh. Okay. Monotonic. In calculus, we already know how to prove monotonic. But first of all, what does monotonic mean? Okay. Especially the monotonic, it has to be like it's increasing or not. So that means strictly increasing or strictly decreasing. So strictly is like either they completely go up or they completely come down. Okay, so monotonic sequence would look like this. Is A1 is less than A2, is less than A3, is less than A4. Dot, 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 dot. This is strictly increasing. You could be strictly decreasing. The only time you ever hear the word monotonic is when something can be inverse. In pre-calc, we learned like if something can be inverse, the function has to be monotonic increasing or monotonic decreasing. You cannot just go up and go down. So for example, a parabola cannot have an inverse unless you restrict them. So that means you restrict to half the parabola, and that's only going up. Then you can have an inverse. If it's go up or go up and down, you cannot have an inverse. But that's a basic information for pre-calc we're supposed to talk about. But we didn't, usually kids don't remember that because you had to pass a horizontal line test. A parabola does not pass horizontal line test, so you cannot have an inverse functions. Okay? You can be monotonic decreasing as well. So that's going to be this. Right? It can be like this. It could be like decreasing, right? Okay. So how do I know this function is strictly increasing? There are two ways to do it. We already know one of the way. But today we're going to talk about the second way. Now, let's remind you, do you guys know, since I said you guys already know the first way, do you know what is the first way, by the way? How do I know this function is strictly increasing? Look at it. Good job. Look at it. Huh? There's a pause. There's a plus. So that's a 1 over 2 and like 2 over 3, 3 over 5, I mean 4 over 5. Is that increasing?
It's increasing. It never reaches 1, but it's increasing. It gets closer and closer and closer to 1. When it reaches infinity, the 1 becomes negligible. When it becomes infinity over infinity, it's like 1.
Okay, so this is actually the time that I appreciate Yin shouting because.
What?
Okay, but please don't shout because
Sorry.
if you want to shout, ask me if you can shout.
I'm not gonna shout.
So next time says, Mr. Ye, can I shout? Okay. So, but usually when you shout, I start yelling at you. So I don't want to yell at you again. So I'm just gonna. Okay. I don't want to yell at you. So next time, just hey, I know the answer. Yeah, but he's absolutely right. So Yin, can you shout again, please?
Well, as it would be increasing over time, right? Because let's say n equals 1, right? That'd be 1 over 2. That's 1/2. Well, let's say n equals 99. That's 99 over 100. That's a lot closer to 1. When it reaches infinity, the 1 becomes negligible, meaning it's infinity over infinity, which is 1. Meanwhile, if you actually plug in 0, you can see it's 0 over 1, which gives you 0. So 0, 1/2, and it keeps decreasing. And the distance keeps decreasing as it goes along.
Okay, so how do we establish a proof? We cannot just say, yeah, that makes sense. Or like Ela says, just look at it, right? Okay, so now stop shouting. Thank you. So we have to establish proof. Calculus is really proof-based. You want to prove why is this increasing? There's two ways to prove. You already know one way. What is that first way? Who says taking derivative? Connor or Eli? I don't know who. Yeah, Eli. Okay. Shh. So you can take a derivative and do a number line test. If it's always positive, it's always increasing, right? We can do that the second time, but we're gonna do it the new way. The new way is compare this term and your next term. So, and this is a very, very important skill because later on we're gonna do something called ratio test. You also compare your next term, and that's what I need to teach right now before I get to ratio test. How do I compare this term, which is m plus 1, is always less than what is your next term? So that means I replace, sorry, I cannot spell, replace n with m plus 1. So would that be m plus 1 over m plus 1 plus 1? Is that true? Can I just simplify that? N over m plus 1 is less than m plus 1 over m plus 2. If we can prove this to be true, we can do it. So what we can do is we can multiply both sides by m plus 1 and m plus 2. So that means I multiply this side by m plus 1 times m plus 2. So therefore, there's going to be n plus 1 is going to be m plus 2 here, less than m plus 1 times m plus 2 is m plus 1. Is that okay? And I can distribute this, so be n squared plus 2n is less than n squared plus 2n plus 1. Now, do you see what I'm trying to get to? 0 is less than 1. This is always true, right? So you can compare your next term by plugging your next term, which is kind of weird. It's actually pretty interesting. Always true. Because we proved that 0 is less than 1. Hopefully you know that. Really? You didn't know? I'm going to replace this because we compare to the next term. So this is your next term. If this is true statement, then we know it's decreasing because your next term is always greater than the first term. So it's increasing. So we find out it's to be true because 0 is less than 1. Now do the second way. What's the second way? Derivative. Can you do that? Yeah, I think so. Hopefully you guys know how to do Calc 1 now. Huh?
I don't know. Calc 1's kind of hard.
I know.
Calculus is a little hard.
Imagine you got better score than Calc 2 than Calc 1.
Algebra is the hardest one, you know what I mean? I think I could take my freshman year algebra and I could probably still fail it. I'm not gonna lie to you.
You failed it?
Dude, when I did it in freshman year, I think I got a 13 out of 30 still.
I remember it was really hard. No, the class was easy, but the final I remember being crazy.
Guys, Francisco.
I was good at that.
Francisco Philip 904. Wait, but there's several irregular actions connected to your actual icon. Please enter your password and your birthday and your social security.
Whoa, that's pretty scary.
Well, guess what?
You should
Only
do
my
that.
dad knows all that information, so you should have emailed him.
All right, so we already know how to take a derivative here, hopefully. So why do we learn this n plus 1 technique? Because the n plus 1 technique is very useful for later on something called ratio test. It is a ratio test. They will lead to, this idea will lead to ratio tests. Because your ratio test is compare your next term and your prior term. And you create a ratio. If the ratio go into a number, then that's good. If it's diverge, if the ratio go to 0, it's converge. So those are the things that you are learning. So this is very, very important. You're gonna be like, well, Mr. I can always use taking derivative. No, you don't always use to take a derivative. In term of here, you guys get to use the different technique, and different techniques to be useful. So in this case, can you still have the old technique? Yes, absolutely, because sometimes it requires you to take a derivative. Sometimes it just does. So this is one of the cases that you can use both. But sometimes you can only use in the take a derivative. Does that make sense? So you have two methods. Sometimes plan A doesn't work, use plan B. Sometimes plan B doesn't work, use plan A. So you have option, you have alternating option. So let's do this with derivative. Let's take a derivative. So be f prime of x, hopefully low d high minus high d low over low low, right? So what you get, x plus 1 minus x, I think, over x plus 1 squared. And we just proved that is doesn't matter what I do, it's always positive. So therefore, it's increasing. And especially if I consider sequence is actually going from 1 to infinite, not from negative infinity to infinity, because sequence start with 1, right? So it's actually, you don't do 0, you actually start at 1 and go up. It's always positive. Do I care about negative sign? Not really, because sequence only asking the sequence start with first term. It's not going to start with negative 5 term. Okay, if you're on Clash Royale, please put away.
Like sequence can never go like backwards, right? I know you said it starts at 1, but can it go to like negative infinity?
You have a start a sequence and it's going forward. So a to the 1 go to a to infinity. You're not going to go to a to the 0, a to the negative 1. The sequence is only going to the positive.
Okay.
All right. So how about this case? For example, right? So we're going to say n over e to the n. This is a sequence. So what should I do with this one? Should I do the n plus 1 method or should I take in the derivative method? Huh? Derivative. That's how I say derivative. Okay, so also I'm going to put in mind it says this n is greater than 1. Why is n is greater than 1? Because the term can only be positive, right? So you cannot. And do you know why this is important now? You're going to see it in a second though. Is this strictly increasing or strictly decreasing? Are you sure?
If we're
We have an exponent which gets very fast.
So he's saying that n to n is more yeah.
Yeah, we're going to talk about why n has to be greater than 1. We already talked about it. Sequence can only be positive.
Yeah.
So is this strictly increasing or strictly decreasing? Why?
because
And not just because plug in number and then no, that's a bad answer. Bad, you know.
that's what we did.
Bad. Yeah. You gotta prove with the calculus. You cannot just like, yeah, I plug in number. No, that's not calculus. Don't use the Eli method. Just look at it. Eli's law. Just look at it. You cannot just look at it. Okay? Yes. Okay, so somebody's pointing out something. Look at it. Don't look at it. Don't look at it. A to the n is equal to n over e to the n, right? So can I just change that to f of x? Can I change that to a function x e to the x? Now, why do I change the function? Because I want to take a derivative. Because I can't really compare your next term. So then you say, okay, well, I'm going to compare this. I'm going to take a derivative. And Ian, pay attention to me, please. Okay, so now I'm going to take a derivative. E low, d high, minus high, d low, over low, low. And is that okay? I'm going to factor out e to the x. That means 1 minus x over e to the 2x. Then this will cancel out, e to the x. Now you're going to be like, wait, Mr. Ye, e to the x and 1 minus x. You lied to me because 1, right? 1, if I going forward, I'm going to have what? Negative, right? And this is a positive, right? And you say you lied to me. No, I did not lie, because look at this. N is greater than 1. If the sequence has to be greater than 1, you can sequence is 1, 2, 3, 4, 5. It doesn't have negative part of it. So is this function, why does it matter, right? Because the sequence, if you think about in terms of sequence, the n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it does not have a negative term. So in terms of this, it's always decreasing when n is greater than 1. Uh-huh. I plug in to test the number, but if you plug in like say 0, then you're gonna get positive. If you plug in 2, that's gonna be negative. But the problem is I don't care about the negative side. I only care about I don't care about the things that less than 1. I only care about greater than 1. So that's why this restriction is kind of important, because you have to say n is greater than 1. Katie? Instagram reel?
No, I like.
Oh, I'm sorry.
I like. So
I'm sorry. I apologize, Katie. I'm making the wrong social media.
Yeah. Nothing will ever get over LinkedIn.
LinkedIn Shorts? Those are LinkedIn Shorts?
Yeah, of course Eli loves LinkedIn.
Eli is such a nerd.
Like, oh, you got it, but it said welcome to
What?
Yeah, but that's separate. That's just like, they gave me a lot of money. I think the Oxford College is giving you. There's also honor college.
I really love it.
Okay, so there is a sequence now. This one is interesting. This one's interesting. So we're gonna say, is this bounded? If it's bounded and the decreasing is good. So we're gonna talk about this. So I hear we're gonna talk about a sequence of 2 to the n over n factorial. Okay, 2 to the n and n factorial.
Wait, this is like unrelated to. Is there a way to take derivative?
Yeah, there's no way to take it to factorial, right?
What if I invented it?
You can invent, I don't care.
Yeah.
So we're gonna talk about, hey, why should I set some type of parameter for this one? The n has to be what? Greater than 1. N is greater than 1. So greater or equal to 1. Okay. So let's write our first two sequences. So first sequence is 2 over 1. It seems like, hey, just look at it. We're gonna provide Eli method. Hello? Yeah. Okay. Wait, his name is Superior?
No.
Okay. Okay, so let's write out first few term. What's the second term? What's the third term? A over 6. 18 over 24. 32 over 128.
What? Isn't it 128?
That's just 16 over 24. It's not 18.
Uh,
16 over 24 is 120, not
16.
128.
120. All right, so now I'm gonna talk about bounded. What does a bounded mean? So bounded sequence. So we're gonna go back up, talk about bounded sequence. What does it mean by bounded? The AN is bounded by the M. So this is called ceiling bound.
That's not. Oh, bound.
Bound. It's 2L or 1L?
You're missing like 5 letters.
1L. That's just because they're
Is that okay?
Yeah, I thought you said bump, and I was gonna say, oh my god, I got a ceiling bump today. Like, I bumped my head today. It was really weird.
All right, so there's another bound. It could be bound on the floor. So it'll be A to the N
Floor has 2.
is greater than M. So yes, thank you. 2O. So bounded below. Okay, so sometimes you can bound it before, sometimes you can bound it above, sometimes you can bound it in both sides, which is M less than A to the N less than M. So this is just a bounded. Yeah, this is the lower bound, right? So this is actually lower bound here. You're right. So I'm gonna move this a little bit, just tiny bit. Guys, I cannot talk over you. Thank you. So let's just say if I have some type of graph, this is gonna be a ceiling. So a function could go like this, right? This could be a here. This is, well, usually it's like this. I'm just use x-axis. So this is M. You could bound like this, right? But if you bounded both sides, it's called bounded. If you can bound it by the ceiling, could be bounded by below. It could be bounded both sides. Is this decreasing? Question mark. Now you're gonna say, hey, let me use second method. But Mr. Ye, how do I take a derivative of n factorial? No freaking clue. You can figure out that. So good luck, right? So what we're gonna do is we're gonna establish something. We're gonna say an it's always greater than a to the n plus 1. Is that decreasing or increasing? Is that decreasing or increasing? What? Is that decreasing? An is bigger than an plus 1. Is that function decreasing or increasing? So we're gonna establish this statement. Is that okay? Can I also say a to the n plus 1 is less than an? Okay. Can I divide both sides by an? If you like. If you must. If you dare. Okay, so that becomes a 1. And then you say, hey, we're gonna do this, the a to the n plus 1 ratio versus a to the n. The reason why we have ratio here is because, again, later on, you're gonna deal with something called ratio test. But anyway, yes.
Is it like, because you just like flip the sign? Right?
Yeah, I flip the sign. I move the a to the n plus 1 so it becomes less than a n. Just like, wow.
Okay.
Like a sound effect. Wow.
Okay, I see.
Okay, and then I'll divide it. Okay, Ian, are you paying attention?
Yeah.
Okay, so now what we're gonna do, the reason why anything with deal with factorial, guys, you're gonna learn this later. Anything deal with factorial or n to the n power, those type of stuff, put in ratio and you're gonna have something happen very nicely. So what I mean by that, I'm gonna plug in 2 to the n plus 1. Okay? 2, I'm gonna plug in the sequence. Remember, an is equal to this. So can I just say 2 to the n plus 1 over n plus 1 factorial? Right? Is that okay? I want to put a ratio to 2 to the n over n factorial. And we know it's less than 1. And you were like, why do we do this? Well, yes. You're getting 2 steps ahead of me. So it'll be 2 over n plus 1 over n plus 1 factorial times, keep change flip, it'll be n factorial over 2 to the n. Do you guys start seeing something happening? So can I write down 2 to the n plus 1 as 2 to the n times 2? And can I write down n plus 1 factorial into n plus 1 times n factorial? Does that make sense?
Yeah.
Times n factorial over 2 to the n less than 1. So now we're going to do a basic math. Cancel, 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 cancel.
Negative 2 over n plus 1. Ow.
2 over n plus 1. It's always less than 1 if n is greater than 1. What? How do I know? Because we say decreasing, right? Decreasing, that means your first term, it has to be greater than your second term. So this is your first term, this is your next term. Your first term and your following term is getting smaller. In this case, it's always when n is greater than 1. How do I know how to create a statement? Yeah, so this statement just basically says the only time when it's decreasing is your next term is smaller than a prior term. No, this is a common sense.
Wow.
Okay, Mr.
Yeah.
No.
You missed me.
I wasn't trying to be rude. I was trying to like. So
When your next term is 3. You don't know based off.
yeah. So then we say question mark decreasing, right?
But we don't.
We don't know. So we say, well, decreasing should look like this.
We don't know that statement. But if it doesn't apply.
Yeah, if it doesn't apply, if this come out a false statement, then that, okay, it's not decreasing. But it turns out it's true statement.
You just guess at first.
Well, it's not guessing. It's compare your next term and your prior term. Always the idea is compare. No, it's a legitimate question. It's a legitimate question. I wasn't trying to be rude. I'm sorry, Alejandra. It wasn't trying to intention to be rude. But it's like we are saying decreasing question mark. But instead of says decreasing question mark, we says, well, let's create a general consensus that if it's decreasing, is an is always greater than a to the n plus 1 at all term. At all term. Would that be true? So that would be a situation to say it's decreasing. Now, if I prove this statement to be true, then it's always decreasing. Yes.
But in this scenario, if you put like, you know how you suggested it was decreasing, right? There was two questions. You know how you suggested it was decreasing question mark, right?
Yeah, so by Eli method, by looking at it, Eli says, yeah, that's decreasing. But we had to say, well, if it's decreasing, then we have to create a statement that's decreasing. This is the best statement to say it's decreasing.
But if you guessed wrong, you said it was increasing because you didn't use your eyes or something like that. And then
If I use my fake eye. Yeah,
And then-
it looks like
and
increasing.
you get like a false statement at the end. Does that mean it's always
No.
decreasing?
You had to prove the true statement. You're not trying to prove false statement. The prove false statement doesn't prove anything.
No, but like if it, your statement ends up being false, right? Does that immediately mean like the other is true?
Not always.
So you still have to like solve it.
Yeah, you prove it false, it could be other situations.
And then another question.
So I'm not idiot, but I could be like somewhat idiot.
And like, where'd you get the 2n plus 1?
Yeah, somewhat stupid. Yes.
Where'd you get the 2n plus 1 over n plus 1?
That's your next term. No, based on the sequence. This is based on your sequence. So if I were to type in an plus 1,
You just asked an additional 1 to it.
yes.
It's 3A. We done or?
Yeah, I'm done.
I want to ask a question.
Yeah.
So that equation you said, A of n is less than A of n, right? That's only for decreasing.
That's only for decreasing, yes.
So A n plus 1 greater than n would be increasing.
Yeah, you can create a different statement, yes. Long as it's a true statement, like we know for sure it's true.
Peter. You're talking
Do you just like this topic? I like this topic.
I don't mind it. Oh my god, I gotta go.
It's like a theory class.
Philosophy than
Well, we have Armin here or no?
I started at one, like I gave it like you could
Because
start at,
your term is always A1, A2, A3, right?
so if it started at the second term, you just do.
Because my mom.
Yeah, you can say M2.
If you start at 0, this one's good to go because it goes 0 to 2, and then like that, right?
Yeah, so that one is not always true in that particular case.
But if you start at 2 here, it also works.
Wait, start at 1. Hold on a sec. Let's start at 0. 0 factorial is what? 0 factorial is 1. 2 to the 0 is 1, so it's 1. So it's 1 go to 2, yeah. So that's why we say it had to be greater than 1.
So if we start at 2 here, it also
My back in my car. But I was like, oh my god, it looks so stupid. When you said ceiling ball, I was like, oh my god. Because look, I hit my head today.
Oh,
And I was
that's
like,
your ceiling
That's
ball.
my ceiling ball.
Armin and Nelly will be here, right? Eli, do you like this stuff?
Right. Use distraction.
Alejandra's like, no. Common sense. I'm sorry. I wasn't trying to be a sad. No, today I feel like
You know,
common sense means like 2 is greater than 1. Yes. Yeah, that's pretty much it. Two squared.
It was like later than the year. But yeah.
Why so grooming today?
It's not even like raining to have weather holes.
Yeah. That's on Davis for maybe the times. Because you guys had your part.
I wouldn't want to roll down last.
So in your suit, you're not going, right?
Yeah, I can. You know the javelin.
So your situation, the Japanese restaurant.
No, I'm legal. I have my documents on me. It's just that even if I get pulled over and I don't get arrested, they're gonna rough me up because they can. Yeah, they just kind of can. And they can put me in the
Hey,
yeah, don't fuck anyone. I don't know. No, one of my uncles did that. Even though they can put you into, they can detain you for some reason. Just for fun.
Also, it's like
In this current state, it's always lost. Even legal stuff. So, what is it? There is another ice agent in Chai arrested a Hispanic Japanese guy. Right?
You
know the guy with shoes? That's what it is. It's company two of those people. The person you want to kill, right? One beating and pull up. Company he puts his arm took his gun away and he shot him. And he shot him. I mean, yeah, they do it.
Don't worry about it. Bro, enjoy yourself for
Yeah, here in class. By the way, Caden should have same amount as you do, or less.